Hello, my friends, and welcome. This is the very first video in our January 2026 AI A to Z series. So, I wish you a wonderfully productive new year with lots of light bulb moments. I'm Dr. Sonali Tamankar, and today we have AI for the cautious. A is for adversarial machine learning. We will conclude today's session with a quick tour of this series. Let's jump right in, though, into adversarial machine learning. You know what all these lovely faces have in common? They don't exist. Now, this would have been a mic drop announcement a few years back, but today most of us have seen images created by AI that look more real than some of us. So GANs or generative adversarial networks are one technique for this. Now, imagine you're a kid learning chess for the very first time. Someone explains the rules to you. Maybe you play with a kid in class. Somebody wins, somebody loses. You learn something. You play more and get a little bit better. Typically, you'll then play with someone better who challenges you more because that's how you grow, right? A worthy adversary makes you better. How does this relate to GANs and these faces of non-existent friends that we have here? The G stands for generative. This is a model trained to create these images. Its adversary is a discriminator which decides whether an image is real or fake. They take turns, much like in a chess game. The generator produces an image and the discriminator classifies it as real or fake. The generator learns from this and then produces a new image that's slightly harder to classify. The discriminator also improves. After many iterations of this process, these models become so good that we humans are no longer able to reliably tell whether the faces in front of us are real or AI generated. A worthy adversary makes both the generator and the discriminator better. But there is a flip side to this. So, as we have seen, adversarial machine learning means models are trained in opposition, and in settings like GANs or robustness training, that opposition is helpful. It's like a tough coach pushing the AI to get better. In the real world, though, the adversary may not be like a coach. It could be an attacker, someone intentionally trying to fool, manipulate, or to break into your system. So here is an example. An AI classifier was trained to distinguish between a banana and a toaster. Easy enough, right? So it learned the task pretty well. But researchers found that if you showed it a banana, but placed a specific psychedelic like looking sticker next to it, then the AI classified it with an extremely high confidence as a toaster. So that might sound funny, but let's get real. Here we have a stop sign. Under certain physical conditions, a few stickers that look like graffiti to us can trick an AI into thinking it's a speed limit 45 sign. So you can imagine the danger if that AI were driving an autonomous vehicle. So, the adversarial techniques can be powerful for generating data and improving models, but they can also expose vulnerabilities that we must defend against to keep our AI systems safe. So, both of these examples come from papers that were published around 2018. So, since then, the state of the art adversarial attacks have become far more subtle and can be nearly invisible. Now, imagine such an attack on a medical image, say like a CT scan that is used by a model to determine whether a tumor is cancerous or not. In an adversarial scenario, a nearly imperceptible change to a patient's CT scan can cause the model to miss a real tumor or to falsely flag healthy tissue as cancerous. So, hope you enjoyed this session about A's for adversarial machine learning so far. So, tomorrow we'll move on to B is for bias and then C is for clustering. If you're interested in large language models like ChatGPT, we'll get there as well. Building through E is for embeddings, and then F is for foundation models, and then G is for generative pre-trained transformer or GPT. Later, we'll also talk explicitly about L is for large language models and concepts like H is for hallucination. Our journey will also include K is for knowledge graphs, one way of giving AI logical structure, and M is for multimodality because our world contains images, sounds, and signals, not just text. We'll cover practical topics like P is for prompt engineering and aspirational ones like Q is for quantum computing. S is for supervised learning and T is for training data will anchor the fundamentals and will also include emerging ideas like V is for verifiability. My goal is to empower Y is for you to contribute meaningfully to AI conversations and to real world adoption. In W is for workflows. This is not a glamorous topic, workflows, but it's critical in determining whether AI will become a white elephant or a true workhorse at your organization. So, throughout this series, our videos will be conversational and accessible with references linked in the description below. So, what questions do you have so far? Please leave them in the comments. So, let's conclude it today with our takeaways for adversarial machine learning. Respect the adversary. Adversarial techniques can be white hat, like improving robustness or model performance, as well as it can have black hat risks, like hidden AI sabotage. So that's it for today. Happy New Year again, and see you tomorrow. Thanks. Bye.